Hello guys, welcome you all for this end-to-end session of AML, DL, NLP, generative AI, everything in order to become a successful data scientist. Hope you guys are enjoying. We are enjoying a lot. We are learning a lot each and every day. Every new thing, see each and every day. Okay. Hope the same thing for you guys. And moving on, like we have completed successfully playing with data, playing with machine learning algorithms, and we have started into a new journey towards deep learning. Okay, where we have completed two different algorithms where we have completed ANN and then CNN. Today we're gonna see the coding part of RNN. So that, as always, please make sure you guys watch all the previous session videos so that you guys can able to understand this. Okay, at least the last two session videos where we have discussed the RNN black box. Okay, the theory concept. Okay, so that only you guys can able to understand what we're gonna talk. Okay, so today it's purely like coding part of RNN. We're gonna see a hands-on of what is RNN. Okay, and one more thing, guys, please make sure that you guys subscribe to our channel and hit the bell icon so that we are uploading everyday new video so that you will be getting notification whenever we upload a new video. Okay, and one more thing, guys, it's gonna be a year-long program. We're gonna cover from basic to intermediate to advanced level. Okay, in search word it is like a breadth first search, and we're gonna do depth first search. Now we are doing depth first search. Okay, so yeah, that's it, guys. So let us jump into today's session. Today's session is all about coding part of RNN. Okay, so let's move on. Okay, so first, what we're gonna do? We're gonna import the necessary libraries, right? We're gonna import TensorFlow, which contain the all kind of layers models that we required for deep learning. TensorFlow.keras.models, I'm just importing sequential. TensorFlow keras.layers, I'm just importing simple RNN for my RNN. Dense layer for the last layer, and NumPy is used to perform some kind of mathematical operation, whereas this matplotlib is used to perform some kind of visualization. Now I'm gonna create my own data. How what I'm creating means my input sequence is 1 2 3 2 3 4 3 4 5. My output sequence is 4 5 6. For example, if I give an input as 1 2 and 3, the output should be 4. If I give the input as 2 3 4, the output should be 5, like that. Okay, hope you guys are able to understand, right? Because RNN treats the data in a sequential manner, so we are giving sequence of input and we are getting the output. Okay, I hope like it's clearly visible for you how the data set is structured, guys. It's completely different than other traditional methods. Okay, now this is how the input should be: 1 2 3, output is 4; 2 3 4, output is 5; 3 4 5, output is 6. Guys, please understand. Okay, so this is our X train, Y train. Now I'm going to have the shape of it simple: three, only three we are having, and then three dimension, and then this is only three. Okay, now I'm going to reshape. Okay, how I'm going to reshape means we're going to have the X train shape of 0, that is 3; shape of 1, 3 1, because our RNN layer can accept the data in this form. Okay, it should be like finally it should be like 1 channel, should be number of channels should be 1. So that's the reason we are reshaping it. Now you guys see here, 3 into 3 into 1, that is 3 cross 3, and we are having a value of 1. Now I'm going to build a simple RNN model. Simple sequential, I'm going to add to the variable called as RNN model. RNN model dot layer, simple RNN. I'm going to use a number of layers to be 50. I hope like ReLU activation function in order to add the non-linearity, because data points going to be non-linear, right? Next, our input shape is xtrain.shape 1 comma 1. I hope like you guys already know xtrain.shape. This is what our input data will be, and the final layer going to be 1. uh, uh, RNN model dot add dense of 1, because we are having output as 1, right? Only one output. 1 2 3 output will be 4. 2 3 4 output will be 5. 3 4 5 output will be 6. Only one output. So that's the reason we have put this dense layer 1. Now when I summarize, guys, just see here, we are having only two layers. One is simple RNN layer and then dense layer. We are having nearly 2000 plus parameters for training. Now I'm going to compile the model using ADAM optimizer together with the last function, that is um, mean square error loss, and I'm gonna fit it so that we gonna train, right? The fit parameter is used to train the model, right? So we are just training the model. RNN model dot fit X train, sorry, Y train, sorry, it's right, X train, Y train, and then epoch is 200. We are giving 200 steps of iteration, guys. Just see here, when I'm training, it starts with 28% of accuracy, and it's gradually decreasing. It becomes 9 8 5 2 1 0.2, it keeps on persisting at 0.2, 0.1, and I hope like after, yeah, 0.00, yeah, perfect. Finally, at 200 step, the loss is 0.0886. That's tremendous for our data. Okay, I'm gonna plot these things. I hope like you guys already know. PLD, like RNN history of loss. The label is train loss and the marker is star. So I'm gonna give the title as RNN model loss. Y label we are having loss. X label we are having epoch legend. So that we will be seeing this label and then show. That's it, guys. See here stars and then starting from the first epoch, the losses keep on reducing till this last epoch, that is 200th epoch, and it becomes zero. Okay, hope till this step that going to be no confusion. Only the data thing we are changing compared to all other models, right? Let's move on. Now moving on, we're going to test the model. Okay, I'm going to have some input like 4 5 6. I'm going to reshape it to 1 comma 3 comma 1 because this is how we have trained our model. I'm going to give it to x test RNN model dot predict x test. So now we need to get 4 5 6, right? Then what is our answer? 7. See here, predict of 0 0, and then I'm just cutting it down to the size of 0.22. Okay, only float value 2 will be there. Now you guys see here we are having 7.36. Okay, so when we give 4 5 6, the model will be producing 7.63. Okay, hope you guys have understand. I will just again go through the things, okay, for you guys, just have an overview of what it is. Okay, so first we are just importing the necessary libraries, what are the things that we need, and we are just creating our custom data set. We are just printing the shape of it. We are just reshaping it so that we can apply it to the RNN layer. We are just building our own RNN layer. Then we are compiling it using Adam optimizer together with the last function. Then we are just splitting it up, that is training it up. So after 200 epoch is completed, we are just visualizing the loss of the function, loss of the model. Then we are just testing the model by using the test sample. That's it. When we give 4 5 6, we are getting 7. So our model is trained. Okay, okay, so this is what the entire flow of RNN coding part. Okay, hope you guys have understand. So yeah sir, over to you.
Yeah, guys. So let us go to this particular. If you come to this session, so guys, go and watch all the previous sessions deeply with long-term objective function and with learning architect called absorb the information, digest and apply, do all the quizzes and all the assignments, and if you have to give feedback, so you give the feedback and have patience, persistency, consistency, and perseverance. So let us go to this particular project application. So RNN, we are going to apply. We have to import the necessary libraries, TensorFlow with TensorFlow keras dot model import sequential because we have to deal with the sequential data. TensorFlow dot keras dot layer import the simple RNN, dense and NumPy and Matplotlib. We have to import all these libraries and prepare the data set. So input sequence, target values, okay, and then we have to okay, so then we have to X train, Y train, we have to, and then we'll get the output, okay, according to that, and we'll see the shape of X train and Y train, and then we go to X train shape, and we'll see, then we'll build the model, RNN model. So for that we have to uh, RNN model equal to sequential. We have to define these. Sample RNN will be 50. Activation function we are using ReLU, and input shape X train. Okay, that we are giving 1 1, and RNN model dot add dense we are going for 1, and then we are getting the output. Okay, so then we have a summary of the model. So sequential model is there. Okay, So RNN model, this is the summary of the model. So layer type is sample RNN, sample RNN. We have output shape, none 50, okay, and then we have 2600 primer numbers, and then we have dense layer, which is one output is there and 50 is primer number. Total primer numbers are 2651, because if you see total, that is density and sample both are together, and then you have trainable primer, which is again same, and then you have non-trainable primer are 0. Okay, okay, so then we compile the model. Okay, and then we do RNN model dot compile, and optimizer is Adam. We use optimizer function as Adam and loss function MSE. Okay, we are using, because these optimization functions will help us to get the better performance, and then we train the model. So here we are training the model, and this is we write RNN history equal to RNN model fit X train Y train epoch 200. So we are giving epoch 200. Okay, so that we want to train it, so that we'll get better accuracy. You can give epoch 100, you can give 300, but uh, so you, it depends how much, what kind of model, and how much loss function, and how is your accuracy and prediction. Like accuracy and loss function should, your loss function should decrease. Okay, and because initially you can see here there is a huge loss function, and then it is decreasing, and you can see accuracy increasing. Yes, so we have, now let's see, it's 0.0886, 0.08 loss function reduced, and you can see the then we have plot for loss function, loss value. So you can see how it has decreased. It has really decreased from 25, like with more epochs you can see it is decreasing significantly. It has decreased. Okay, and it's a very significant change. Okay, then we go to test the model. Okay, when here we are going to test on np.array and 456, data type is float 32, reshape 131, predict value RNN model, predict x test, print f predicted value for input. We have 456, and then we are going, we'll see this is as output, which is 7.63, predicted value for input. Okay, whatever input we have given. So yeah, so can we go to the, yes, that's it.
Yeah, that's it, sir.
So this is the model. Guys, go and mimic and imitate this particular assignment, and do as it is what we have done, and keep learning deeply with long-term objective function with patience, persistency, consistency, and do reinforcement learning. Learn these all the previous sessions and this session 5 to 10 times. Go watch, absorb and digest, then go and apply. Okay, 90% is absorb and digest, 10% is apply, and then you will do wonders. Keep learning with long-term objective function. Thanks.
Yeah, guys, that is all about the RNN coding part. Okay, so we have discussed entire coding part of RNN, and we have intimated you that there is some problem with RNN, right? Exploding gradient and vanishing gradient. Those things we're gonna suppress by using models such as LSTM and GRU. Let us connect for that for the further classes related to those models. Until next class, bye guys, take care. And one more thing, I hope like you guys are able to understand, right? Any one thing that you guys are not able to understand, anything that you guys are struggling, just post in the comment section. We'll take up and we'll solve your doubts. Okay. So until next session, bye guys. Take care. We will all meet in the next session. Bye guys.